Okay, before we get started, this actually continues some notes we started on before we had to leave school. This is in the chemical bonding notes, part 2. So if you want to pause right now and go grab those notes, you can do that. You can just fill in, or you can just kind of listen and take notes on your own, or of course rewatch this if you need to. Yesterday we learned about polyatomic ions, what they were. Today we're going to kind of put those together into compounds. They can form compounds actually with one another. One of them is ammonium is a positively charged cation, so it can form a compound with all of the negatively charged polyatomics. Or these things, the negatively charged ones, can form compounds with just about any metal. And ammonium actually can form a compound with most nonmetals. So we're going to look at these compounds. Are also called ternary ionic compounds. Today we're going to work on what they are in the naming. The next lesson will be about writing the formulas. Going back yesterday, some polyatomic ions, some examples. SO4 2- is a sulfate ion. This is a polyatomic ion because it has an electrical charge. Remember, compounds do not have electrical charges. They may be made up of charged particles, but their overall charge is negative. Neutral. That's not the case here, so we have to call these ions. A few examples: SO4 2- is a sulfate ion. PO4 3- is a phosphate ion. This is a special case. Ammonium, it is the only polyatomic that we're going to have to deal with that has a positive charge. There is a complete list on page 7 of your reference table of these ions. It gives their name, it gives their charge, which is of course also their oxidation numbers. So you don't have to figure that out, that's given to you. There's a video posted right after this one that shows you actually a picture of page 7, and I'll talk about a little bit about what's there and how to use it. Key thing with a polyatomic is the whole thing must stay together as a unit. They do not break apart. So we have to add them in whole units, and these things act like single element ions. And they will bond ionically with other single element ions of opposite charge or a polyatomic of opposite charge. And some examples. This is a polyatomic formed by the magnesium 2+ ion in the sulfate polyatomic, which is -2. This is a compound formed with the +1 ammonium ion, polyatomic ion, and then the -1 chloride ion. And then this thing here looks a little weird, and it looks weird because of these parentheses. There's only one place you're going to see parentheses, and that's in the formula of polyatomic compounds, and then you're only going to see them if we had to add a subscript when we wrote the formula. We'll talk more about that on the next assignment when we go into writing these formulas. But for right now, just know that if you see parentheses around something, it's a dead giveaway. That's a polyatomic. That's the only place you're going to see them. Of course, we have polyatomics over here that on the other two examples, we didn't have parentheses. And that's because we had, with the case of magnesium sulfate, a +2 and a -2. Here, ammonium is +1. Chlorine's -1, so we didn't have to add any subscript. That works pretty much just like when you wrote the binary ionic compounds formulas. We'll talk more about that in the next assignment. Some examples, and I'll go ahead with the name of these. We looked just at these. This is magnesium sulfate or Epsom salt. These are fairly common things. Ammonium chloride, and then ammonium sulfate. Okay, the rules for naming these compounds with polyatomic ions. The rules are almost exactly like naming binary ionics. There is only one difference, and that is you never, ever change the name of a polyatomic ion. If you do that, you get it confused with single element ions. We do change the endings of the anions to IDE. You do not change the endings of the polyatomic. So if it's sulfate, it's sulfate. If it's nitrate, it's nitrate. You don't change that. So the rule's pretty simple. Name the cation in the compound. The compound could start with ammonium. So if that's the case, instead of a metal ion, you're just going to say ammonium. Again, you never change it. Then you name the anion. If the anion part of it is a polyatomic, you use the name off the list on page 7 of the reference table. Page 7. If it is a single element anion like chlorine or fluorine or oxygen, you do use the IDE. So you can have something like ammonium chloride, ammonium fluoride. And then if you have a transition metal, remember something like copper, manganese, iron, any of those. If you have to use the compound, and we'll do an example of this and figure out the oxidation number of it, whether it's like this would be copper 2+, so it would be copper 2. You do have to do that same as you do with binary compounds. So some examples. Remember rule 1, we write the name of the cation, and I'm going to put the polyatomic names in red and the single element things in blue, just so we can kind of see what's going on. So this is magnesium. Our next part is a polyatomic. We look at our list and we see that it is sulfate, so we're just going to write magnesium sulfate. Magnesium is a group 2 metal. It only is always +2, so we don't have to worry about any Roman numerals with this one. On our second one, we see the formula starts with an N, and we know nitrogen's not a metal. So the next thing I'm going to look for, see if there's a H4 behind it. So lo and behold, yeah, we have ammonium. So I'm just going to write that. And then what's left is just chlorine, so I'm just going to do chloride. I am going to change the ending of the name of the chlorine because it's a single element. You do still do that. The next one, we're starting with a metal, potassium. This is a group 1 metal, so we don't have to worry about the oxidation number in the name. And then this whole mess here is acetate. It looks kind of messy. This is actually an ion you're pretty familiar with because it's in vinegar. It has a very distinctive, that vinegary smell. Anything has that vinegary smell, pretty much there's some acetate around. This next one looks terrible, complex, but it's really not. First of all, we got these parentheses. Remember, that's a dead giveaway that we have a polyatomic. Starting with N is also one. So what this is a compound with 2 polyatomics. So this is ammonium. And we look at our reference sheet and we see that this is dichromate. Okay, for our last example, Au is gold. Gold is a transition metal. Remember, all transition metals except for silver, zinc, and cadmium have to have a Roman numeral in their name. That's also the case, remember, for lead and tin. They act like transition metals. So we've got to figure out the charge. And we got to do this the same as we would always do this. Let me slide this up so I can get a little working room here. Remember, the sulfate is, we look at the, I'm going to go ahead and write this down, since we bothered to look it up, and then we'll figure out what the oxidation number is for the gold and add those parentheses in. Remember, the sulfate is -2. There are 3 of them. Has to add up to 0, so this is just like dealing with binary ionic compounds. So we have a total of -6 of charge. We have 2 golds, so to get a total of +6 over here, I'm going to do a couple of +3s. So this is gold 3 sulfate. Okay, rewind if you need to. Take a look at this. There is a little bit of practice. I've got it in as a quiz just so that you get some feedback. Remember, when you're doing this, you have to, if you're putting Roman numerals in, they have to be uppercase I's in parentheses. A space between the parentheses and the anion and cation names, just kind of space it out. The computer grading is kind of picky, but go ahead, try, good luck. If you don't do so great the first time, just look at where you went wrong and try it again. Thanks.